Now, in both of those examples, we had a positive and a negative, so they automatically canceled each other out. This is called elimination using addition. But sometimes, if you look at problem 4, we have a situation where we have the same variable and the same coefficient with the same sign. They're both positive. So this is where we're going to use elimination with subtraction. So at this time, I'd like you to copy problem 4 on your own paper. When you were learning how to subtract integers, if you had something like 5 minus 10, we taught you to do keep, add, the opposite. So you would have kept the 5, changed the minus to plus, and changed 10 to its opposite, being a negative 10. And then you would have calculated the answer as negative 5. Well, this same concept applies to system of equations. So what's going to happen here is instead of adding these, because 2x plus 2x would equal 4x, we're going to subtract. And I'm going to keep the first equation as it is, change the minus to plus, and then I'm going to change every term in the second equation to its opposite. So instead of positive 2x, this becomes negative. Instead of plus 2y, we're going to change it to a negative 2y. And instead of a positive 6, we're going to change this to a negative 6. Then we're going to go back and add just like we did in the previous examples. Our x terms are lined up, and they're now going to cancel out. They're going to be eliminated. My y terms are lined up. So 5y, take away 2y. 5 minus 2 gives me 3y. And then my constant terms are lined up, and a negative 3 and a negative 6 combine to make a negative 9. So my x's are eliminated. I can solve for y. Cancel out your 3's, and I get y equals negative 9 over 3 simplifies to negative 3. Now that I know the value of y is negative 3, I can substitute this negative 3 into either one of my original equations. So I'm just going to pick the first equation, and you don't always have to pick the first. You can pick the second. So I'm going to recopy the first equation, 2x plus 5. Replace the y with the negative 3. And then solve for x. 5 times negative 3 is going to give me negative 15. Add 15 to both sides. Bring down your 2x. Negative 3 plus 15 is the same as 15 take away 3, so that's going to give me 12. Divide by 2, and I get x equals 6. So my solution, x is 6 and y is negative 3. So let's try the subtraction method again with a different problem. Let's look at problem 9. So copy problem 9 on your paper. On problem 9, I have negative 4c minus 2d equals negative 2. The second equation, I have positive 2c minus 2d again. Notice we have the same variable and same coefficient, same sign, equals negative 14. So for me to get the negative 2d's to cancel out, I'm actually going to have to subtract. And I want to keep the first equation, change the minus to plus, and then change every sign in the second equation to its opposite. So instead of positive 2c, change it to negative. instead of minus 2D, change it to positive, and instead of negative 14, change it to positive. Now I'm ready to line things up, and I'm adding now instead of subtracting. So these are going to end up canceling out. So negative 4C and negative 2C combine to give me negative 6C. The negative 2D and positive 2D have canceled. They're now eliminated. Bring down the equals. And negative 2 and a positive 14 now, that's the same as 14 take away 2 is 12. Divide by negative 6. And I get C equals negative 2. Since my variables, I have C and D, that's going to translate over to X and Y. Let's take the C that equals negative 2. And again, I can substitute that into any of the equations. Since I've been substituting into the first equation, let's substitute into the second equation this time, just to prove to you that it all works out. So instead of 2C, I'm going to write 2 times negative 2. The negative 2 came from right here. Then bring down the minus 2D equals negative 14. Now simplify. 2 times negative 2 is negative 4. Now you have a two-step equation to solve. Add 4 to both sides. Bring down the negative 2D. Negative 14 and positive 4 give me a negative 10. Cancel out my negative 2's and divide by negative 2 on both sides, and I get D equals negative over negative makes positive. 10 divided by 2 is 5. So my ordered pair for my solution, C is negative 2 and D is 5.